Hey students, I got another great question here, so let me try another video solution. This is number 35, and this is a lot like the one I just made a little while ago, 32. So take a moment to take a look at that. It's a unit conversion, also that same video I said on little tricks on unit conversion. And again, this one like 32. It's a little harder though. You can see it's labeled blue instead of the black one like number 32. And I think because here they don't give you all the unit conversions, and it doesn't really look like a unit conversion. So I think that's why the author elevated it to a blue problem here. But let's give this a go around. And like I said, probably worth your time to watch number 32 first and then come over here to 35. But it says here, calculate the number of cells in a hummingbird, assuming that the mass of the average cell is 10 times that of a bacterium. So I guess my first unit conversion, and it's may not look like it because we don't typically, talk about cells as a unit, but that's what we're talking about. How many cells do we have? And in this case, I'll convert it into mass because this says one cell is about 10 times a bacterium. And a bacterium is listed in the reading of the book. It's also listed in number 32. Let me just look on your PDF. Oh, there it is. It says a bacterium is about 10 to the minus excuse me, 10 to the minus 15 kilograms. So if we think of this as 10 to the 1 and we add exponents, this becomes 10 to the minus 14 kilograms is the mass of one cell. And so that's kind of the first bit of information, the first unit conversion that we could convert from mass into the number of cells. And ultimately then this will be that important step because it says calculate the number of cells. So we're going to need this. And clearly we need to get that from mass. And so the other thing we need to know is something about the mass then of the hummingbird. And this is where I don't think it was in the reading of this book. Maybe is what makes it hard. They're going to ask you to do a little experience here. If you've ever seen a little hummingbird about yay big or something, kind of hold it here. And it's a bird, so it's really light. It has hollow bones. Looking around here on my desk. I don't know, maybe this is a hummingbird, but... And maybe it's roughly that same weight here. And it's a penny is about 3 grams, so clearly it's more than a gram. It's not even close to 100 grams. So in terms of order of magnitude, I'm just going to say, one hummingbird is roughly 10 grams, Well, why not here? Okay, and that'll be my conversion. Now, I'll say that with a little bit of openness. I mean, if you were to guess 5 grams, 6 grams, that's fine. In fact, I bet I would be surprised. Hummingbirds, the birds are really, really light. Yeah, it wouldn't surprise me if it's even less than this. It's 5 grams. Actually, I would just feel better if I went down to 5 grams. Okay, so I'm going to go down to 5 grams. Okay. Because, you look at something that size, but, half of it's feather and the other half of it's hollow bone. Well, not literally, I guess. Maybe a quarter's feather and a quarter's hollow bones. And it's only half as much as you think it might be. So I'm gonna go with 5 grams. But again, I think you're doing the problem right if you put, 3, 4, 5, 6, 10 grams. I think if you get up to 100 grams or as low as 1 gram, you're kind of not getting the gist of a 1 gram here. All right. So coming back to focus on this then and just, saying, okay, about, okay, 5 grams is my hummingbird. Let me start with then what do I know? And I'll say this is what I know. I know that, there is 5 grams in one hummingbird. Okay? And that I won't change. What I want to do is eventually convert the units from how many grams per hummingbird to how many cells are in a hummingbird, okay? And so this is where I say kind of this magic happens, where we have to do some unit conversion. We want to say switch from, whatever units we have, which in this case is grams of per hummingbird, to the number of cells, okay? And kind of heading in that direction, knowing here, of course, this is in kilograms, maybe the first thing to do is to say, why don't I take this gram and convert it into kilograms? So my first thought then is to say, put a gram on the bottom and a kilogram on the top. That's my technique for unit conversion, because as I multiply this now, grams are going to cancel with grams, and I'm going to be left in kilograms. And the only way to justify multiplying it by 1, or multiplying it by anything, and 1 doesn't change it, is that the numerator is the same as the denominator. So let me make sure the denominator, which is 1,000 grams, is the same as 1 kilogram. So you can see that the numerator and denominator are the same. That's equivalent to the number 1. And so I haven't really changed anything, but other than the units now, if I did this multiplication, I would have the number of kilograms per hummingbird. And that's good, but not quite there yet. Because now I want to get rid of kilograms and convert it into something I know, and that would be the number of cells. That's cool. So this multiplication also needs to be a 1, and so I need to make sure what's in the numerator, 1 cell, is the same as what's in the denominator. So 1 cell is equal to 10 to the minus 14th kilograms. And if it's strategically set up, the kilograms will cancel off, and I will get the number of cells. Okay? And so looking at this, it looks like I've converted grams into kilograms, good. And then kilograms into number of cells. And so when this arithmetic is done, I'll have the number of cells per hummingbird, which is the question. Calculate the number of cells per hummingbird. Okay, nice. So now grabbing my calculator here, I will take this 5, and I won't bother to divide it by 1. That doesn't change anything. Then multiplied by 1, I won't bother with that. But I will go then divided by 1,000, okay. Then multiplied by 1, I won't bother with that one. Then divided by 10 to the negative 14. Now, just as a little side note, there's 3 ways of getting that on your calculator here. I like this one. 1, and you use the EE. And in my calculator, I got to get to the secondary function, the blue one. So I go second EE, and then negative 14. And so that means times 10 to the negative 14. Now, I guess if I wanted to, and I guess I'll just show you in passing, it would also work to go 10 and then use the caret of negative 14. That's the same thing. And I'm not sure it really matters for this particular problem. In fact, I see that it really doesn't matter for this particular problem. But I think most of the time the scientific and the exponential form here works a little better. So I'm gonna use it. All right, and go back to it and then hit enter. And so this has me at 5 times 10 to the 11th cells per hummingbird. And like I said, this 5 is very flexible because I did 5 grams. And so if you decide to pick 4 grams, this is going to come out to be 4 times 10 to the 11th. If you decide to do 10 grams, you're going to come out to be 10 times 10 to the 11th, which you might want to write as 10 to the 12th, and so forth and so on. Okay? And part B is really doing the same thing. It says, making the same assumptions, how many cells would there be in a human? And so I'll call this A, but I'll do B kind of the same way I just said, that you could, have a slightly different number here if you were to put, 4 grams instead of 5 grams or 10 grams. So let me just put in a human. And so instead of putting 5 grams, I would put the mass of a human. Now, again, humans vary, but a rough idea is humans are, around 70 grams. I wish I could keep my weight down to 70 grams. I'm thinking more like 75. Probably I'm up 77. But why don't I just roughly say a human is 70 grams? Okay. Now, doing a little bit of unit conversion here. In fact, very easy in the metric system, because the kilo actually means 1,000. So I'll just replace what the kilo means. And so if you remember from lecture, kilogram means 1,000 times a gram. And then I'll just put it that way so that I can then put those numbers together. And so this is just 70,000 grams. And that means I can just do part B by saying the number of cells in the human body then would be 70,000 times 10 to the 11th. So I'm just, again, replacing the 5 grams with 70,000 grams. Now, that's kind of a weird way to write it, so let me do a little better. I could think of this right here as 7 times 10 to the 4, which, of course, also times 10 to the 11th, and then add my exponent, so this becomes 7 times 10 to the 15 cells per human body. And again, it would kind of vary. Bigger humans would be up here at 100 kilograms. And so that would now become a 10, and that would become like 10 to the 16th. Smaller people under 70 would, say 60 kilograms, this would be a 6. 50 kilograms, we're probably not an adult human at that point, maybe, would be a 5. I don't think we should go all the way down to 10. Yeah, 10 would be like 25 pounds. I don't think any human, at least adult human, is 25 pounds. Anyways, I think that's probably a good number for how many cells are in a human. All right. Hopefully that was helpful. Take care.